Hi students, Ms. Culver again. Part 2 of our video. We didn't know there was going to be 2 parts. We thought there was just going to be 1. So you will see when you're learning section 1.2, you'll see a 1.2 part 1 video and a 1.2 part 2 video. Maybe that's for the best. So when you come down here, notice that we completed it. And so I figured that we didn't have to redo this part. You know where those come from. So notice that as you approach a value of x of 0 from the left and the right, that the value of the function, the y value, is approaching 1, like we felt we saw on the calculator. So we put the limit as 1. At an actual x value of 0, notice that the value does not exist. Notice these two are different. That's not what a limit is. A limit is just x approaching 0, not landing on it. Okay, this is evaluating a limit numerically. A little tedious, but at least it's kind of easy. Let's go over to number 3. Let's evaluate limits graphically using a graph. This is a graph of the function f, and just so you know, when you take the AP exam, there's going to be a picture that looks almost just like this on there a couple times. Again, piecewise functions are the rule, not the exception in AP Calculus. Let's do here what you already know. You know how to find the values of these functions. So let's find the value of the function where x equals 2. Of course, we're looking for the y value. Let's go to where x equals 2. And when I go to where the function is occurring, that is a y value of 2. F of 3. Let's go to x equals 3. Let's hit the function. Oh, that's an open circle. That means there's actually no value where x equals 3. We're going to put D and E. Does not exist. F of 1. When we go to where x is 1, oh, look at that. It almost looks like there's 2 values, y values, where f is 1. But you know this is an open circle, this is a closed circle, and so the y value, the value of the function, is actually 1, where x equals 1. Let's go to f of 4. There's where x equals 4. When we go up, oh, that's easy to read, your y value is 4. So this is what we already know how to do. Let's evaluate some limits. Okay, so let's evaluate the limit as x approaches 2 from the right. So I am going to approach 2 from the right. Right here, I'm moving towards 2 horizontally. And what I'm going to do is just follow the value of the function as I move horizontally. So as I approach 2 from the right, notice that the function value is approaching a y value of 2. Let's find the limit as x approaches 2 from the left. So as I approach 2 from the left, with my finger, I'm just going to follow along on the function and see what y value it's approaching. So as I approach 2 from the left, I'm traveling along the function on the left, and I see a y value of 2. So how do I evaluate the limit as x approaches 2? That would exist if the value as you approach 2 from the right and from the left are the same. So because the limit as x approaches 2 from the right and the left are 2, the limit as x approaches 2 is 2. Let's check the limit as x approaches 3 from the right. So as I approach 3 from the right, I'm following along on the function, and the y value seems to be approaching 3. Now you may say, but Ms. Culver, there's an open circle there. We are only approaching 3 from the right. So if it really messes you up, cover up the function where x equals 3. You're only approaching 3, not landing on an x value of 3. So now as I approach 3 from the right, the value of the function I can see clearly is approaching a y value of 3. I don't care what's happening underneath the marker. That is f of 3. Let's approach 3 from the left and see what the function is doing. As I approach 3 from the left, the value of the function is also approaching 3. Because the right limit and the left limit are equal, the limit as x approaches 3 does exist, and it is 3. Let's approach Let's find the limit of the function as x approaches -2 from the right. Here's -2. As I approach from the right, I'll follow along on the function, and the function doesn't seem to be approaching any value. It seems to be approaching infinity. So what I can write here is either does not exist, because that limit doesn't exist, we're approaching infinity, or you could give the reason why. You could say does not exist, perfectly acceptable, or you could say that it's approaching infinity. That is a reason why the limit doesn't exist. Let's find the limit as x approaches -2 from the left. As I approach -2 from the left, notice again that the value of the function is approaching infinity. So we will say that that limit does not exist. If you feel like it, you can put or approaches infinity. That's the reason why it doesn't exist. Please remember over here, when we were talking about the definition of a limit, that for a limit to exist, it has to approach a real value, a real number. Infinity is not a real number that you can name. So the limit as x approaches -2 does not exist. Or you could give the reason and say that it approaches infinity. Let's take a look at the limit as x approaches 1 from the right. As I approach 1 from the right, notice the function that is happening is this line right here. As I approach 1 from the right, the value of the function is approaching 1. Let's check out the limit as x approaches 1 from the left. Notice I'm also going to go on the left. Notice as I approach a value of 1 from the left, this is the function that is happening to the left of 1, not this one. So as I approach 1 from the left, I am riding along this function, and that seems to be a function value of 2 that we are approaching. Again, if it concerns you about what is happening, that open circle there, we are not evaluating f of 1. Cover it up. We're only approaching it. As I approach 1 from the left, the value of the function is approaching 2. So notice the limit as x approaches 1 only exists if the limit is the same from the left and the right and exists. These are not the same. So even though there's a limit on the right and a limit on the left, because they're not the same, the limit as x approaches 1 does not exist. Okay, let's take a look. What's our conclusion? How does the limit as x approaches c of a function relate to the actual value of the function? Well, let's take a look. Here, the limit as x approaches 2 is 2. Oh, and the value of the function is also 2 at 2. Okay. Here, the limit as x approaches 3 is 3. But take a look, the value of the function doesn't exist there. On C, the limit as x approaches -2 does not exist, and I didn't have a comparable one there. Just mixing it up a little bit. The limit as x approaches 1, that limit does not exist, but notice it actually has a value of the function there. So my conclusion is what I said before. The limit as x approaches c may or may not be equal to f of c. You just have to evaluate them separately. One does not rely on the other. Okay, let's go over to number 4 here. Let me get a red marker. So, what are reasons why a limit doesn't exist? Right, we have 3 written here. Here's some reasons why a limit would not exist, or DNE. A limit could be unbounded. Unbounded means approaching infinity or negative infinity, right? We saw that on 3C. Let's go over here. On 3C, we found that the function was unbounded. It was approaching infinity, right? That is a reason why a limit might not exist, due to unbounded behavior. Okay, we already saw that. What's another reason that a limit might not exist? That might happen when limits from the left and the right are different. That's our 3D. Let's take a look over here. We saw here that the limits existed from the right and from the left, but they weren't the same, so the limit did not exist. Okay, so when you have limits from the left and the right that are different, you will find that a limit does not exist. Okay, this is actually called a jump discontinuity, right? We will learn more about that later, but take a look. Let's go over to this graph. Look where x is 1. See how the y values are jumping. That's why the limit doesn't exist. We have a jump there. Okay. Now, here's one that we didn't see, but I think is super cool. A third reason why a limit might not exist is due to oscillating behavior. So let's take a look here. We're going to put this on the calculator. What is the limit as x approaches 0 of sine, we're going to be in radian mode, in a trig window of 1 over x. Now, obviously, you can see when you try to put a 0 in for x that the value doesn't exist. But that's okay. We're just approaching 0. Let's find out what the function is doing. And we're going to zoom in to really take a look. So we're going to come over to the calculator here, and we're going to get really close. I already made sure I was in radian mode. And I'm going to clear out my function here. And I'm going to put in sine of 1 divided by x. Okay, I'm in radian mode. I'm going to hit zoom 7. Again, a zoom 6 would be fine. I'm just going to look at the graph and see if I can kind of tell what's happening where x is 0 or as I approach 0. You know, when I look here, it would seem as if I approach an x value of 0 from the left and the right, it kind of looks to me like the limit might be 0. I think the y values are heading towards 0, but it's really hard for me to tell. So let's zoom in. Let's hit zoom and number 2. Let's zoom in. And you have to hit enter for the calculator to do something. Oh, wow. Look at that. There is a lot going on there. And when I check my, my window, notice I'm in between x's of -1.5 and 1.5. I'm pretty well zoomed in. But wow, I don't know. Is it as I approach 0 from the left and the right? Is the function approaching 0? It's hard to say. Let's zoom in again. So let's do zoom 2. Hit that enter button. Let's see what the function's doing. Holy cow. Look at all that. Look at all that is going on with that function. I'm going to hit the window button in between a -0.4 and a 0.4. Isn't that crazy? All those things you couldn't see. So what's actually happening here is the limit does not exist. For the limit as x approaches 0 sine of 1 over x, the function is oscillating wildly in between y values as you approach 0. I thought you might think that's cool, everything that's going on that sometimes you can't see. Our last problem, let's go over to number 5. This is number 32 in your book. And what it's asking you to do is sketch a graph of f of x that satisfies the given values. So we have these 4 conditions that we have to meet here. Believe it or not, calculus takes some creativity. So we're going to get really good at that. And so what I'm going to do is, with this problem, the very best I can. Let's try it. Let's see if green shows up. So here's the 4 conditions I have to meet. F of -2 equals 0, f of 2 equals 0. The limit as x approaches -2 of the function has to equal 0. But the limit as x approaches 2 of the function has to not exist. All right, I'm going to do the easy stuff first, right? I know how to draw. That marker doesn't work. I know how to draw f of -2 equals 0. I'm going to go to where x is -2, and I'm going to put the point -2, 0. There we go. Okay, that's easy. All right, this is easy too. F of 2 equals 0. All right, so when you're doing these graphs and you need a little creativity, do the easy stuff first. All right. Next, the limit as x approaches -2 of the function has to equal 0. Okay. All right, and I try to use the simplest stuff I can. How about if I just use a horizontal line where y equals 0? Let's take a look. So I am going to approach what makes this limit exist is when I approach -2 from the left and the right, that the value of the function, the y values, approach 0. So how about if we just keep them 0? Here we go. I'm going to approach -2 from the left. Notice that all these y values are 0. Okay? And as I approach -2 from the right, I need the y values to be 0. Oh, okay, that was easy, just a horizontal line. All right, here's the kicker. I need the limit as x approaches 2 to not exist. All right, let's keep it as simple as possible. Well, let's just keep going, right? A function has to have a value at x for every y, so these all have to be filled in. All right, so I'm approaching it. Now, what can I do to make this limit not exist at 2? There's two things I could do. Either I could make the left and the right y values not equal each other, right? I could have a jump so that the limit doesn't exist, or I could have some kind of unbounded behavior, like something head towards infinity. So let's try this. How about if I just do a simple jump? What if I just say, as I approach 2 from the left, that the y values are approaching 1? Just a nice horizontal line. Take a look. I've met all the conditions. F of 2, 0. Sorry, f of -2. F of 2, 0. Notice that the limit as you approach -2 is 0. Notice the limit as x approaches 2 from the left and the right does not exist because there's a jump. As you approach from the left, the value of the function is 0. As you approach from the right, the value of the function is 1. Notice I had to put an open circle here. For this to be a function where f is 2, you can only have one y value. So I had one closed and one open. What else could I do? I could simply go like this. As I approach 2 from the right, I could just have unbounded behavior. From the right, it's approaching infinity. This limit doesn't exist. So you can get a little creative. And that's it for today. As I said, the notes usually aren't this long, but I wanted to go really slowly and carefully. So our last thing is just be super kind to yourself and to others today. Thanks for hanging out with me and the squirrels. And next time we'll include my cat, Princess. Thanks so much. Have a good